As you know, I'm really interested in forest ecology and in land use change. And that means I'm curious about questions that are things like how and why does deforestation happen? And what are the ways that we can most effectively use forests for climate change mitigation? Specifically in this dissertation, the question that I ask is, how does land use policy for forest management impact forest outcomes? The land use policies I'll describe in a minute, and the forest outcomes that I'm looking at are really deforestation and forest carbon for the most part. To give you some context around this question, you want to know that global forest cover has decreased 46%, and that's really since the beginning of human civilization. So it's over a long time period. More recently, the trends are a lot more varied. For example, in the last 100 years, in North America, forests have been increasing, while in places like the Amazon, forest cover has been decreasing. Second, of course, forests provide really important services. You'll find this in any introductory environmental science textbook. Forests are important for nutrient cycling, for recreation, for timber, for non-timber forest products, for carbon storage, all sorts of important uses and things that make them really interesting and important to study as well. And third, more forest data are available now than ever before. This is partly because in the last decade or two, we have just a lot more satellite data that tells us about forest cover. We also have, of course, much increased computing power, and there's really more funding for forests than there has been for a long time, mainly because of this interest in forests for climate change mitigation. This is an example of an online platform called Global Forest Watch, which is run by the World Resources Institute together with some researchers at University of Maryland and a number of other partners, where you could go online today and you could look at the last 16 years of forest change in whichever area you're most interested in. The blue is showing forest cover gain, and the pink is showing forest cover loss or tree cover loss. The purple is kind of like our election map. It's something in the middle has been happening. So there's just tons of new data. It makes a really exciting kind of area to be doing research in. Today I'm going to talk specifically about 4 chapters I've been working on, and the first 2 are about deforestation in the Peruvian Amazon. I do research in this region because actually there are pretty good data for Peru, and also because it's a really kind of a typical tropical forest country. It has an average deforestation rate, and it's really struggling to decide how it wants to manage its forests, both for conservation and for development. And so in that sense, it can provide lessons not only for Peru, but for other tropical forest countries. The first chapter I look at in this category is overlapping land use allocation. And by land use allocation, I mean the government has allocated land for something like a national park or for a timber concession. And these uses are occurring on the same piece of land at the same time in the overlapping case. And second, I'm going to talk really briefly about private concessions as well. Then in the next section, I'm going to look at forest carbon in California. And the reason that I do research here is because California is really running a first of its kind program looking at forest carbon offsets. And so we want to understand more about how is it doing this offset production on one hand and offset use on the other hand. To give you a really basic sort of framework or schematic to think about these questions, I would show you this very simplified diagram, which is that often you have a land use policy, which will impact the way that forest management is done, which in turn impacts forest cover and forest carbon storage. And often that result goes back and impacts the land use policy at the beginning stage. You'll see an interesting example of that in the 4th chapter. Here today, as I said, in the first chapter, the policy I'm looking at is overlapping land use allocation. In the second, it's private concessions. And in the 3rd and 4th, it's the forest carbon offset program. So I'm going to dive into the first chapter now. And what's really interesting about overlapping land use allocation in Peru is that it's been an issue recently. This is an article from a couple of years ago where there was a major conflict between 2 different parties who felt that they had been allocated the same piece of land. It turned into, unfortunately, a large conflict, and a number of people died over this issue. In addition, as I mentioned, Peru is really in the process of balancing its needs for development and conservation. Palm oil has been in the news in many tropical forest countries for a long time, and it's really gaining a foothold in Peru, and Peru's trying to decide sort of What are its priorities? Where is it going to do conservation? Where is it going to develop as forest land? And the third thing that's really recent, this is just showing you last month, but Peru has a really big problem with illegal deforestation. It's estimated that 80% of its timber production was actually illegal, is generally illegal. And this is just behind DRC and Laos. It's a really high percentage, and it's been causing the country a lot of problems. Just last year, they had some major timber shipments that were seized, actually, in the US and not able to come into port. So with this context, both on the side of land use allocation and deforestation, the question we wanted to ask was, how does overlapping land use allocation influence deforestation rates in the Peruvian Amazon? And the way to think about this question is that you've got your overlapping land use allocation. So again, that's one piece of land that's allocated more than once for different purposes. And you might think that this would incentivize deforestation, that there would be higher deforestation in these areas. And what we think about here is land tenure insecurity as a theory. If you don't know that you have secure access to your land, you may be incentivized to just go in and extract resources as quickly as you can. On the other hand, this might disincentivize deforestation, the overlap. So you'd have less deforestation. And the theory that we think about here is multiple use theory, that sometimes maybe actually it's more efficient for forests, for use of forest land, to use the same piece of land for multiple purposes. Of course, the overlapping land use allocation might be anywhere along the spectrum, and also it could be here in the middle with no change. The study area that we look at here is just the Peruvian Amazon, so that's the green area on this map that you can see. And the deforestation data look like this. This is from 2000 to 2014. You cannot make out the colors of each year, but you can see relatively that this is what it looks like to have a sort of average rate of deforestation. It occurs in different types of patterns for reasons that I won't go into a lot of detail about here. But these are from Landsat data, so these are 30 by 30 meter pixels. And they were processed using ClassLight, which is a software platform developed by the Asner lab. And they were verified in partnership with the Asner lab and the government of Peru. For this study, I actually scaled them up to 1 hectare, and that's because the government sort of standard for deforestation is a 1 hectare parcel. So that's what I'm dealing with in the data. We also need to know about the land use allocations, and this is what they look like in the Peruvian Amazon. So the areas that have no color are not allocated for something. The light gray, I think you can see, is been allocated, but just for one thing. And the darker colors, shades of gray, are multiply allocated. So you can see that most of the Peruvian Amazon is allocated for something. And actually, there's a fair amount of multiple allocation as well. What are these land use allocations? I divide them into 3 groups. On the far left, you can see there are uses that are mainly for conservation. These are things like national parks and protected areas. On the far right, these are allocations for commercial uses, so for oil blocks and logging concessions and uses like that. And in the middle is this combination of uses that are some conservation and some commercial purposes, like ecotourism concessions. The method that I use for this study is quasi-experimental difference and differences matching. It's quasi-experimental because we can't randomize this sort of overlapping scenario. And the difference in differences then looks at the treatment group and the control group. In our case, the treatment is this overlap, and the control is areas that have been allocated but only one time. And we look at, in the treatment group, the observation of forest cover at time 1, the change at time 2. We compare that, and then we also look at the difference between the treatment and the control at time 1 and change in time 2. For matching, we also need to control for all of the covariates that we think might affect both the treatment, this allocation, and the control, or the outcome, the deforestation. So for this study, the covariates that we use are slope, elevation, agricultural suitability, which is a combination of soil and precipitation data mostly from Peru. We also use distance to road, distance to river, distance to city, and department, which is like a state in the US. With these covariates, what we do is we assign a propensity score, and that's, you can think of as like the likelihood that you will have deforestation in a pixel. So you need to consider all of these things together, come up with a propensity score that will tell you something about that likelihood. And here's an example. So let's say on the left, these are the control parcels, 1 hectare parcels, and each one has been assigned a propensity score, which is a combination of those covariates. On the right is the treatment So those are the overlapping areas, in this case an overlap of a conservation and a commercial type area. And you're looking to match the propensity scores so that the likelihood is the same in the comparison that you're doing. For example, you might find two that are 2.31 in each case. You bring them together, and then you get this set of matched hectares, and this is the set on which you'll look at changes in deforestation. So once you've done this matching process, you compare the deforestation. And that works like this. Let's say this is our singly allocated for conservation. We see that these orange squares, 2 of the 9 are deforested. So we say that's 2 right there. We also need to look at the singly allocated commercial type. And here we see we have 4 of 9 deforested pixels. We actually, to do the comparison now between these two and the overlap, we take the average of them. So the average of the 2 and 4 is 3. And then we look at the overlap area. Again, we see 3 deforested pixels. Now we can compare these two and say, it's the same. There was actually no change in deforestation. Alternatively, of course, you might find here there are 2 deforested parcels in the overlapping area. So you compare the 2 with the 3, and you would say, OK, this is disincentivizing deforestation. In fact, what we find across all overlap types is that there's disincentivized deforestation. Anytime there's an overlap, no matter what type it is, there's lower deforestation in that area. And this is surprising. There's been a lot more literature kind of over in this realm, looking at land tenure insecurity and the importance of land tenure in deforestation. But the idea of the multiple use theory is that, it may be more efficient to use land for more than one thing. And we're also thinking about this as potentially a conflict avoidance strategy. If you know there's a place where somebody else may be competing with you for access to resources, maybe you're just going to avoid it. Here's the data just to give you a little more detail on these results. So this again is for change in forest loss from 2000 to 2014. You're comparing a singly allocated area with the overlap. So for example, on that top line, you see the overlap of a conservation area and a mixed conservation and commercial area has 0.2% less deforestation than if you just have the single allocation for conservation or for mixed areas. So these results range between -6 and -0.2, so they all show a disincentivized deforestation. With that, I'm going to turn just really briefly to talk about the second chapter on private concessions in Peru, and this is focusing now on just these commercial area types that I was telling you about, so oil blocks, logging concessions, Brazil nut concessions, and rubber concessions. And the question we had was, how do sustainability commitments made by private concession holders impact deforestation rates? This is really an interesting question to look at right now, first because these kind of sustainability commitments, which can take many forms, are really proliferating quickly. And there have been a number of studies looking at how they may impact deforestation, but the results are mixed. We don't have sort of a conclusive finding on what their impacts are, and even sort of at a sort of finer scale level, looking at types of sustainability commitments, we don't have an overall finding. And in this case, it's a really unusual one because we have sort of multiple sectors of data for the country of Peru that we can look at, and we can look at the entire population of these private concession holders. So of the 4 types that I just told you about, there are only 2 actually we find in our analysis that have made any kind of commitment. The first is oil concessions that have made some kind of external sustainability commitment. And the second is logging concessions that have made some kind of external sustainability commitment. In the case of oil concessions, the commitment is usually an ISO environmental management standard, which we expect to include less deforestation. And in the case of logging concessions, it's a certification, a voluntary forest stewardship council certification, which also includes provisions that you would expect to decrease deforestation in those concessions. We use the same, of course, allocation and deforestation data, and we also use the matching method again. And actually what we find, unfortunately, is that there's no difference between a concession that has made a sustainability commitment and one that hasn't. There are 2 reasons why we think this would be the case. One is that the commitment may not be rigorous enough to really show a difference between the concessions that have made some commitment and those that haven't. This is the most commonly cited reason for when you don't see some kind of finding. The other possibility is that although these concessions have made some kind of commitment to be environmentally responsible, the monitoring is not adequate to ensure that they're meeting these commitments. So again, in other studies that have been done on this topic, the results are really mixed. Sometimes you do find a big difference in deforestation, other times you don't. And so certainly there are more studies to be done on why and when you would expect to find a difference. The most recent study that actually also looked at logging FSC certification in Peru also found, unfortunately, that there was no difference in deforestation. So if I return to my original schematic here, thinking about land use policy, impacting forest management, impacting forest cover, and for each of the first two chapters I just told you about, on the left-hand side, overlapping land use, and on the other, looking at sustainability commitments, as I said, the land use policy in question is, in the first case, the overlapping land use allocation, and in the second, private concessions. And in the first chapter, what we saw is that potentially the forest management issue of interest is either multiple use or conflict avoidance. And the forest cover change that we saw was a decrease in deforestation when there's an overlap. In the second chapter, the forest management interest is sustainability commitment, whether a concession has made a sustainability commitment, and we don't see any significant change in deforestation here. So that is everything that I want to tell you about those first two chapters, and now I'm going to turn to California. So as you probably know, California has this Global Warming Solutions Act, which it passed in 2006. It's been in place for 12 years now, hard to believe. And by 2013, they had started sort of the flagship part of this act that's supposed to be doing climate change mitigation, which is the cap and trade market. And the cap and trade market in California includes compliance offsets or legally enforceable offsets. By 2016, there were 39 forest offset projects that had been credited in the cap and trade market. And these projects, which I'm going to tell you more about, are the projects that we analyzed in this chapter. I'm happy to say that I got to work on this with a fellow E-IPER student who did his master's and a joint law degree here, Jason Perkins, who's now a lawyer in Indiana. And so what we did was a document analysis of all 39 of these projects, looking at all of the project data, and actually the carbon data, characterizing the carbon modeling. We also did an interview of all of the project participants and stakeholders, interviews with project participants and stakeholders, and we did a survey of all the project participants and stakeholders. And that is the data that we used. So how do forests, I want to tell you first then a little bit about how forest carbon offsets work. The idea is that in California we have this cap and trade program, and so large greenhouse gas emitters like power plants or cement plants or refineries have a cap on the total amount of emissions they can produce. And either to meet that cap, they need to reduce their own emissions, or they can trade with another emitter to get the credits that they need so that they can continue emitting, or they need to purchase offsets from someone outside the system. And here in California, the most common and popular kind of offset is a forest offset. The way that this works is a forest owner will say, I will store additional carbon in my forest, additional to what I would have otherwise. That carbon will be measured and verified, and then I'll be able to sell that as credits to the greenhouse gas emitters. You can imagine in that scenario, forest offset project, a whole bunch of other restrictions on what you do on your forest and requirements. So you might wonder, as I did, sort of what are the seeing differences for recreation, for endangered species, or for other kinds of co-benefits. So our first step in the analysis was to look at these projects, and this is what the forest offset projects look at like. You can see that they can be located actually anywhere in the US, even though they're credited in California. About 17, most of them, about 17 are located in Northern California, and the others are all over the US. And they really range in size. The size of the dot is showing you how large the forest is. They range from 500 hectares all the way up to 100,000 hectares in the Upper Peninsula of Michigan. And most of these dots are green dots, and that's indicating the project type is improved forest management. So that's the project type I was telling you about. A forest owner has standing forests. They model and agree to change their forest practices to store more carbon, and then they get credits based on that. The most common type of improved forest management actually that you see in this program, to give you a sense, is expanding your rotation length. So imagine you say, normally I would harvest these trees every 25 years. Now I'm going to just harvest every 30 years and have some additional carbon stored. So with this sort of initial data that we put together, we had two main questions. The first is, are forest offsets good for the climate? Are they actually providing this benefit in California's mitigation system? And the second is, are these forest offsets good for other reasons? Are they providing other co-benefits, as I alluded to? So on the first question about forest offsets and their impact on the climate, I want to tell you three things about our analysis. The first is that offsets are really a fraction of mitigation efforts. So in 2006, California's emissions were around 478 million tons. By 2015, we were down to 440 million tons. And in that same year, the total number of offsets used between forests and some other types of offsets was this 4.7 plus 3.4, you can see at the bottom, about 8 million tons. That's about, total offset use is about 2% of all emissions in that year. So it's relatively small. And this is a good thing. You really, in a mitigation program, you don't want to have offsets as your main tool. As I explained, the greenhouse gas emitter who purchases an offset is still going to continue their emissions. And what we need in the long run is to really decrease all of our emissions everywhere. So we need to really encourage greenhouse gas emitters, the large polluters, like refineries, like cement plants, like electric plants, to find ways to actually reduce their emissions. So you want offsets to be a small part of the program. What's really useful about them is they bring additional stakeholders into the program, forest owners that wouldn't otherwise be participating, and they provide a way for lands to be incorporated in our mitigation work. But you still want them, in an offset sense, to be a small part. So that's the first part. The second thing from our analysis that I want to tell you about is that credits are deducted for risk and uncertainty. We found that on average, when a forest owner goes out and has a forest inventory done and has it verified, they get to keep this green portion, 80% of the credits that they've accounted for as being additional carbon in their forest. But 20% they don't get to receive counted for risk and uncertainty. And on average, 19%, that sort of almost pink color, are deducted based on the reversal risk. So each forest owner has to do an assessment of what is the risk that my forest is going to totally burn down next year, or it's going to be infested with some kind of disease that's going to kill the trees. And based on the level of risk, they need to submit a portion of their credits into this buffer pool, which is like an insurance pool you can think of, that any project owner could draw from in case they face some kind of catastrophic loss of carbon. And the other part of credits that aren't received is this 1%. On average, it's 1% for project owners. And that's the confidence deduction. And that's based on when a forest hires professional foresters to go out and do the inventory. There's some sampling error that they find. It's usually more than 1%, but it's sort of a scaled deduction that you take based on what is the size of the error in your actual inventory of the carbon. So this is a positive thing, that the program is accounting for risk and uncertainty. I would say one of the limitations that we find here is that there are other types of risk and uncertainty that could be accounted for. You can imagine that in the future, with changed climate, we have different levels of risk for wildfire. We have different levels of risk for disease and for drought. And we also have different rates of carbon storage in our forest because of climate change. And those things are not yet accounted for internally within the program. So there are certainly some limitations. That's the second thing. The third thing I want to talk about briefly is indicators of additionality. The state has a whole bunch of requirements. That means that you want to show that what you're doing in your forest, that you're storing additional carbon to what you would have otherwise stored. If you're just going about business as usual, you were always growing these trees, you never intended to cut them down, you're continuing to grow them, it's not something that's additional. It's not additional sequestration that should be credited. And we looked at two indicators to try to understand what direction the program is pointed in terms of additionality. And the first is forest ownership. I really thought when I started this assessment that we would find that a huge number of the project owners were nonprofits who, again, hold forest land, really don't harvest it, never intend to harvest it, and are going to try to get credit for continuing what they've always done. But we find in this indicator, actually, that the ownership of these projects is really diverse. More than a third are held by companies, and you also have tribes, investment firms, individuals, and a quarter who are nonprofits who are project owners. A number of these nonprofits, incidentally, are also doing active logging. So the second indicator, which that leads us to, that we wanted to look at was active logging. How could we understand whether, if a project owner says, well, I was going to cut down, but now I won't, and I'll claim the credit, was that really going to happen? And the indicator that we looked at here was the forest owner harvesting any timber in the 5 years prior to joining the project? Again, I thought this number would be really low, but we were surprised to find that about 66% of project owners actually were actively harvesting just in the 5 years before they joined the program. So these are two indicators for additionality that we were able to analyze in our assessment. Now I want to turn to that second question, which was, are these forest offset projects good for other reasons? Are there code benefits? And from our analysis, it looks like yes. Forest offset projects do come with co-benefits. These are based on voluntarily reported data in the document analysis, which largely match actually with the survey data that we collected. And on the y-axis, you can see the co-benefits that we measured: conservation easements, endangered species, hunting access, water resources, recreation, and wildlife. Almost every project reported on some kind of co-benefit voluntarily. And you can see, for example, that almost half of projects report having some endangered species on their land. So we do see, even based on voluntary data, it looks like there are some co-benefits in addition to the climate change mitigation benefits that we see from these projects. So far, based on this really first of its kind initial program, it'll be really interesting to see how the program changes over the years, because this is data based on the earliest projects started a long time ago in 2001, but the compliance program has been online for only a few years. So it'll be really interesting to see how this changes. That's what I want to tell you about offset production. And I'm going to turn to offset use. I got to work on this chapter actually with an undergraduate here at Stanford named Kendall Kissel, who's a freshman and did a CSER project this summer. She did some great research looking at greenhouse gas emissions at stationary facilities in the state. And the question, or the issue that really arose after we had done this research about offset production was that actually people really cared a lot more about the use of offsets. As you might know, California has a long-standing problem with poor air quality. In many areas, we've been out of compliance with federal and state regulations for clean air for a long time. And so we have all these air quality regulations, including the state implementation plans, which is how we tell the federal government how we're going to come into compliance. And these are meant to be improving our air quality. When I'm talking about air quality, I'm mainly talking about co-pollutants that are really important for human health, like particulate matter, two different sizes, particulate matter 2.5 and 10, and VOCs are volatile organic compounds, which are precursors to ozone, which matters a lot for human health as well. On the other hand, we have now all of these climate change regulations, including the cap and trade program, which I told you about, and in particular, its offsets component, which I'm going to be looking at here. And then we have a lot of other policies. Interestingly, it's actually these other policies that do the lion's share of the work of the climate change mitigation in this program, but we're focusing on the offsets here. And what we don't know is really what is the impact of these climate change regulations on this air quality issue, the human health part of air quality. So the greenhouse gases that we're mitigating in climate change regulations, mainly carbon dioxide, are separate from the co-pollutants that really matter for human health, and we don't know what kind of impact these climate change regulations have on the co-pollutants. The place where this is especially a big issue is in disadvantaged communities. They're the gray dots on that map of California. Disadvantaged communities are formally designated or defined by the state based on sort of a whole bunch of criteria, but two broad groups. And one is they have really poor air quality, and the other is that they have demographic characteristics that otherwise put them at risk. So for me, personally, I live up in Vallejo. We have some of the worst air quality in the Bay Area. Most of Vallejo is a disadvantaged community. And I was really curious to understand, in these disadvantaged communities, the concern was power plants and refineries and other facilities are maybe buying offsets instead of reducing their own emissions. When if they would have just reduced their own emissions, we might have seen all of these other improvements, not just for mitigation, but also in air quality. Is that the case? Is it the case that when we use offsets, we're sort of missing out on these potential air quality improvements that we could see locally, especially in disadvantaged communities? And I was really personally interested in this question. So I'm going to tell you about two parts of it only today. Two of the several parts that we looked at are, first, are offsets used disproportionately in disadvantaged communities? So we wanted to understand, is this a problem that's especially impacting disadvantaged communities where air quality is already bad? And this is interesting because the state law, actually, the law that passed the Global Warming Solutions Act, specifies that you cannot disproportionately impact disadvantaged communities in any of your climate policy. And the second question is, are these decreases in greenhouse gas emissions for climate change mitigation, are they correlated with decreases in other co-pollutants? So would we expect to see some kind of co-benefit in terms of air pollution if we were just decreasing greenhouse gas emissions and not using offsets? So on the first question of disproportionate offset use, here's what this looks like a little bit. So the purple dots you can see, the gray areas again are the disadvantaged communities. The purple dots are showing you where there's a facility, a greenhouse gas emitting facility located in a disadvantaged community. And the orange dots are all the facilities that are located outside of disadvantaged communities. I'm going to zoom in here on the Bay Area so you can get a little more picture, and also on the Los Angeles area where there are actually a lot of facilities. You can see down where we are in Palo Alto in the Bay Area, there just aren't a lot of large facilities, nor are there a lot of disadvantaged communities. You won't be surprised to know. But what we see overall for the whole state is that in the orange bar, offsets represent 4.7% of total emissions outside of disadvantaged communities. And in comparison, offsets represent 5.1% of emissions, total emissions, in disadvantaged communities. So the offset use by share of emissions is slightly higher in disadvantaged communities, but it's a very small difference. On the second question of sort of what do we see as a relationship between decreasing greenhouse gas emissions and decreasing co-pollutants, what is the importance of that? I'm just going to show you one figure, which is this one. Here we're looking at greenhouse gas emissions change. So this is in tons per year normalized on the x-axis. And then the outcome on the y-axis is co-pollutant emissions change, also tons per year normalized. The black line at the bottom, that's the previously assumed relationship. So the state in all of its modeling to try to say, what are going to be the benefits, the health benefits from this or that measure, they use this assumption that greenhouse gas emissions will change in a one-to-one relationship with co-pollutant emissions. What we found from our analysis, and this is looking at data for more than 600 facilities in the state, and from 2008 to 2014, is that the actual relationships look like this. I'm just showing you 3 of them here. There are more co-pollutants. I'm showing you particulate matter 10, PM 2.5, and VOCs, which are the precursors for ozone. And the observed relationship is actually much gentler. So you can see it's about, if you reduce your greenhouse gas emissions by 1%, you might expect these other co-pollutant emissions to reduce by like 0.3 or maybe at most 0.4%. This is really interesting because it provides us new data by which we could update sort of the models actually that the state is using and that many, many people are using. Because it's hard to look at this, it's hard to know what is this relationship in many cases. California has better data than most other places, and so we were able to do this analysis here, but it's certainly a question in many other places as well. So if I return to my original schematic here, looking at California, the land use policy in question is the Forest Carbon Offset Program. The forest management we're interested in is this sort of formal improved forest management as a technical term. And the forest carbon, that change that we see is increase in forest carbon because of the offset program. But we also do see this small potential loss in air pollution emissions reductions, these co-pollutants. If we had had no offset program, there probably would be slightly lower co-pollutant emissions, not as much of a change as we'd previously assumed, and it looks like there isn't a big difference between disadvantaged communities and non-disadvantaged communities, but there is that loss. And what I think is really interesting about that 4th chapter is that it gets to this 3rd arrow linking back to the land use policy, because in fact, because of this concern about the air pollution impacts of using offsets, the state last year, when it renewed the cap and trade program, actually halved the total offset program. So they said it used to be that you could use, account for 8% of your emissions as offsets, and now in the future we're going to go down to 4%. And a big part of that was because of this huge concern about air pollution. Unfortunately, this was before we had done this analysis or had the data, but it shows you a really nice example of how this sort of like loop gets closed. I also think it's a really nice example of why we do interdisciplinary research in E-IPER. Because if I had just followed my circle, which is sort of where my spot is and where I like to do research, I would have missed this totally important other influence that people really asked me a lot about after I finished the third chapter, saying, wait, well, we're really worried about where these offsets are used actually, and what are these broader impacts? So I think it's a nice way to recognize that you really need to follow the question and be willing to go outside of your traditional area of expertise. Those are each of the 4 chapters I wanted to tell you about. If I were to tell you in summary what I think is really interesting and important about each of these, in the first case, I was looking at overlapping land use allocation in Peru, and we saw a decrease in deforestation. If I were to leave you with one point of, I think, what's really interesting to know about or follow up on here, it would be that overlapping allocation we see does matter, but it might not be the first sort of priority for forest conservation. In my previous work, I worked in conservation development for the Forest Service, mostly in sub-Saharan Africa, and many times when we were funding a forest conservation project, the first sort of funding that we would put in would be to say, we need to look at land tenure and regularizing land tenure and having a map that doesn't have any overlaps, et cetera, et cetera. This is one initial point that says, well, maybe if what you're really worried about is forest conservation, that wouldn't be the first thing that you need to fund. I don't mean to diminish the importance of land tenure security. I think it's definitely super important for many, many reasons. But it'll be interesting to see more research on this topic specifically relevant to forest conservation and overlapping land use allocation. For the second chapter, I was looking at private concessions, and we didn't see any significant results in terms of change in deforestation because of sustainability commitments. And I think the point that I take away from this is that really we need to continue monitoring these sustainability commitments because they're rapidly increasing in use, because we see mixed results from other studies. We'll be working to develop further, I think, theories about when and why they can work and when they don't. In the third chapter, I was looking at this forest carbon offset program in California, and we saw an increase in forest carbon. And the interesting thing here is this is really a proof of concept. As I said, this is a first of its kind program. And what I think is really important about it is that it demonstrates a way that forests can be a part of climate change mitigation policy. I don't mean just as offsets, but I mean thinking towards a bigger, broader picture of how can you include lands in your forest or in your overall climate change mitigation policy. The state of California previously really hadn't included forests at all, and it's in the process now of thinking about not just offsets, but for all forest land, what are the kinds of things that we can do for mitigation? And this provides us sort of some initial information about that. And in the last chapter, I looked at the forest carbon offset program again. We see increase in forest carbon, but because of the pollution sort of concerns and potential losses in pollution benefits, we're decreasing the overall size of the potential forest carbon contribution in terms of forest offsets. So I put that as a sideways arrow. And I think this is a really interesting demonstration of the real trade-offs that exist between using offsets and your air pollution improvements that then impact land use policy, and of the importance of really looking at sort of all the factors that may influence this cycle of land use and forest management. This gives you just a glimpse of the research that I've been working on for the past years, and it's been really fun to tell you about. As you've heard, there are so many questions that are now opened up that I would love to work on in the future, but not alone. I want to use this as a segue to say that certainly I also didn't do any of this work alone, and I'm really grateful for all of the support and help I got from many, many people along the way. I can't thank you all individually right now, but I look forward to doing so in the coming weeks. Thank you.
Exactly 10:45, and we would love to have about 10-15 minutes of questions, and then the committee can go to our other room. So, Christa, I'm happy to kind of look around for hands, but I think you probably know most of the people in the room. So I can let you.
Sure. Yeah. Yeah.
That was very provocative. Thank you. I have a couple of questions on the 4th chapter on the copollutants.
Mm-hmm.
So if you could put up the figure with the slopes.
Yeah. Yeah, and unfortunately, I should have brought it back up. This is grossly simplified, as you can see. But yeah.
Yeah. So I guess my first question is if you could explain that.
Yeah.
If I was to excitedly leave this and go tell somebody the underlying evidence for your conclusion, I would need to understand this a little bit.
So we had previously, nobody had just looked at sort of, when we look at the data from 2008 to 2014 for all the stationary facilities in the state, what is the relationship between changing greenhouse gas emissions and copollutants? So that's what we looked at. And the state, because they hadn't looked at this, they were just using this assumed one-to-one relationship, which many people have used for a long time because we don't know the answer. So with the data that are reported from stationary facilities for these 3 copollutants, but also for about 7 others, this is a linear regression. We also did some mixed effects models. Generally, they all correspond and agree that there's significant relationship, that it's not as strong as this one-to-one relationship, but that it does show that when you reduce your greenhouse gas emissions, you also reduce copollutant emissions. I would also say, though, we don't have information about why did those emissions change, right? So in the future of the cap and trade program, we expect that there will be a lot more reductions in greenhouse gas emissions, and facilities will have to undertake specific measures to try to reduce their emissions. So this relationship would probably change. Since we're looking at data from 2008 to 2014, there wasn't a ton of pressure in terms of reducing greenhouse gas emissions on these facilities, and so we're looking at relatively small changes. This particular iteration is showing you just decreases in greenhouse gases. It's not looking, I say change, but it's not looking at the increases. We did look at that, though.
All right, thanks.
Does that make sense?
Then just the related question is, have you also quantified, or do you have any insight on not the effect of the offsets, but but of buying up pollution rights? And in terms of underserved communities, yeah, because
outside communities just buying up sort of permits.
Well, no, if I'm the refinery in Richmond, I can buy offsets for somewhere else, but I can also buy an emission right. Then it's going to be emission locally. Yeah. So do you have a sense of the magnitude of that effect relative to this offset? Yeah.
So there are even 2 things. So you are compelled to buy an emissions right, actually for all of your emissions, or some of them you're granted for free, right? So there's that isn't as interesting to look at as what would be super interesting to look at is if they're trading with other facilities, right? Which is sort of very similar to using offsets. Unfortunately, the state is not releasing that data. So the volume of trades, they just released data on all, which includes mostly these intermediary trades happening between third parties of credits. So we don't have data on to what degree is the refinery trading with someone else to get the credits they want, unfortunately. Yeah.
Going back to chapter 1, when you mentioned that, maybe you mentioned it, but you mentioned that there's like different allocations in the same area. And I was curious about if these allocations belong to different stakeholders or are the same stakeholder, or you have a notion of that. How that may be played in explaining a little bit.
Yeah, I meant to say that. So basically, when you have an overlapping allocation, in this case, many studies look at these sort of informal overlaps, but these are all formal. They're done at the federal level by the government of Peru. And sometimes it's just sort of accidental, right? Different ministries are in charge of different kinds of allocation. And sometimes it's sort of purposeful, like, oh, it's not a big deal if you have an overlap between this logging concession and this oil block. But basically, they're all from they have different individuals or companies who are title holders for those. In every case, I'm not aware of any case actually that's sort of the same title holder that's like, I have a logging concession and I have a oil concession. It's a good question though. I thought much about that. Yeah.
Was it surprising to you at all that the total emission from disadvantaged communities was lower than non-disadvantaged, or is that a function of just the number of locations designated as disadvantaged?
Yeah, it's a function of the number. So basically, disadvantaged communities end up being about 25% of the population of the state. So you could think, oh, maybe then they have 25% of the emissions. They don't, they have way more than 25% of the emissions because they do have more of these kinds of facilities. But as a total number, it's less than the non-disadvantaged communities. Yeah. Yeah.
Well, on a follow-up to that, I mean, is there data out there that says like the relative productivity of those facilities in the disadvantaged communities compared to the non-disadvantaged communities, like the efficiencies of the pollution or of the regulation of that? So are they more efficient? Is there data?
We might be able to look at that. That's an interesting question. The main way that we looked at that so far is that we disaggregated all of this. I didn't show you any of it by facility type. So as I was saying, there are refineries, there are cement plants. They all have different types of emissions and different kinds of efficiencies. And certainly there's been a long concern from the environmental justice community that disadvantaged communities have some of the worst polluting facilities like refineries that we have up by Vallejo. When we look by facility type, we don't see any sort of hugely drastic differences in terms of either offset use or this relationship. But it would be interesting to do a more granular look at sort of their actual efficiency at a facility by facility level. Yeah.
Great presentation.
Thank you.
Still puzzling over the fact that the sustainability requirements and commitments were not really making much of a difference.
Right.
Hypothesized it might be because the requirements were not strenuous enough or the monitoring wasn't good enough. I'm just curious about the nature of the sustainability relationship. In other words, who did they make the commitment to? Government, NGO, whether there was funding attached to it. Did you kind of that question of the nature of the sustainability commitments, perhaps making less effective and in some cases more effective?
Yeah. What surprised me was that we weren't able to go very deeply into that because, for example, for the logging concessions, there was only one type of commitment present, which was this FSC certification. And the FSC certification is a voluntary, nonprofit thing, but you as a forest owner or concession holder, you have to pay to participate in that program. And the idea is that you'll be able to sell your product at a higher value because you've got the certification. If I found a difference anywhere, I would have expected it to be under the FSC certification. It has a reputation as being, the strongest type of certification for logging. And so it's interesting that we don't see that. For the oil concessions, they actually did have more diversity in terms of what commitment they made. So basically, a lot of these are sort of large multinational oil companies, and they've made all sorts of different commitments. They're basically most of them are pretty informal commitments, and so I divided them into two groups. And what I didn't say, but I was showing you on the map, is that the first group is this sort of internal commitment that companies have made. So that's the first group is like, and honestly, most of them, what the commitment, they say, oh, we're really environmentally responsible. And what we do is we follow all the laws of the country. That's sort of the level of commitment that they made. And so then we differentiated that from this other group of oil blocks that had said, we participate mainly in this ISO 14001 environmental management sort of scheme. Which is also voluntary and which you also have to pay for, but is not at least perceived to be as stringent as something like the FSC certification. Does that help you?
I have a question on Chapter 3 and additionality. So when you showed your map of 39 locations for forest offset projects in the U.S., I'm pretty sure that some of those locations correspond to private companies that are selling credits into other environmental markets. And so I'm wondering, in your analysis of additionality, you also said that the plot that showed that some of those projects are providing benefits, for example, for endangered species that have these other lower markets being so offset. So I'm wondering if you looked at how the program is addressing potential additionality concerns surrounding other environmental markets, and if so, what do you think about that?
You mean other environmental markets that are not carbon markets? Oh, yeah. Yeah, okay, yes. So what is interesting is that this has been a huge issue in offsets in the past, is like you shouldn't be able to one idea says like you shouldn't be able to double dip. If you're gonna get credits for offsets, you can't get credits for other stuff in this property, But the California program, when they set it up, they actually took exactly the opposite approach. They said, we basically want to do climate change mitigation, but we're totally unopposed to getting other benefits from this land. And so if you can have other types of kind of project level or market level co-benefits that you get money for, that's great. In our survey data, we didn't find, and none of the projects are doing that actively. There are a few that are trying to, and the two that I can think of that are actually actively would like to sort of monetize another co-benefit in their forest are trying to do some wetland work. You know, so you can do wetland banking and sell that to blah, blah, blah. Nobody has successfully been able to do that yet. But, and yes, there are a bunch of questions around additionality that are normally raised in that situation. I think that whether you really care about additionality of like every single ton on this exact project, or if you care about additionality as like overall, is this program additional? You know, sometimes it's undercrediting, sometimes it's overcrediting, but on the whole, you have an additional program.
We'll do one more question. Somebody would like to have it. Somebody has a great question. No pressure.
So first of all, congratulations. It's really great work. I just want to go back to this project concession question. FSC in particular is actually not focused on no deforestation, right?
Right.
It's on sustainable management.
Yeah.
So could you say a little bit more about what you're able to tell, how what's going on the ground, and what more you would want to know?
Exactly. So FSC covers a whole, to get certified, you have to meet a whole bunch of different criteria, and each country has its own standard and list of criteria. So in Peru, for example, there are many criteria that are about responsible and sustainable forest management, which we are not measuring by looking at change in deforestation. So that would be great if we could sort of actually more thoroughly assess how are they meeting those objectives or not, right? All we're looking at is forest cover change. There are about 6 of the requirements that are directly related to forest cover change, for which you would expect to see, I think, lower deforestation. So you have to have this sort of conservation set aside, which you normally don't have to have in other concessions in Peru. You have to prevent, I think the really big one is you are compelled to prevent illegal logging in your concession, which is super hard to do, but would definitely lead to lower deforestation. You also have to have a number of measures around when you're doing harvesting to minimize your impact so that you're sort of taking out the minimum number of trees and not causing big clearings that would especially show up in the satellite data. And then there are a couple of others around sort of conservation of species, which you would expect to be correlated with lower deforestation. So we think that we should see lower deforestation from FSC certification, but at the same time, we're not able to evaluate the effectiveness of the certification on other criteria. My thinking is that the sort of baseline is that you would see a change in forest cover. If you don't see that, are you going to see these other things? It's hard to say. I'd love to have some more data on that. Time to go to the field.
Okay, well, thank you all for coming. I'd like to invite you to at 1 o'clock join us on the terrace, which is kind of just through where that red hall is out there, or you can also go around kind of in the direction as well. So thank you, Christa, and the committee will convene upstairs at 182. Sue was saying weather dependent and may not be on the terrace. Otherwise, it will be in the suite, which is also another. Great. Thank you, everyone.